Hello, everyone. Thank you for being patient while we got a few things set up with our software on our end. I want to thank everyone for being here for today's webinar, Consumer Electronics, Designing with Flexibility for Reliability, brought to you by Design World Magazine and Ellsworth Adhesives. We'd like to thank our presenters, Ryan Schneider and Jason McGough, for being here today. I'm Mike Santora, Associate Editor for Design World Magazine, and I'll be your moderator. Just a couple of housekeeping details before we get started. You'll see several boxes on your desktop, all of which can be moved around to suit your preferences. Initially, the Q&A box is at the lower left, and this is where you will enter your questions for the Q&A session. Another box to note is the additional resources initially at the lower right-hand corner of your desktop. These resources are for your information needs as well. We also have a tweet box right on the desktop, so feel free to tweet any interesting points right from there. And lastly, there's a list of hashtags for you to use as well. Ryan Schneider joined Dow Corning in 1993. He worked with a variety of specialties within the electronics industry, including low dielectric thin films for interlayer dielectrics, vacuum insulating materials with low thermal conductivity silica, and silicone-based materials for lithium-ion batteries. In 2013, he began his current AETS role supporting electronic, adhesive, and protective materials for consumer, communication, and transportation electronics. Also today, we have Jason McGough with us. McGough is an engineering sales representative with Ellsworth Adhesives in the Silicon Valley area. He has been helping customers specify engineered adhesives and tapes into the industrial and electronics markets for over 12 years. So, without further ado, here is your first presenter, Jason McGough.
Hi, everybody. Thanks for joining today. We're going to start by talking about some consumer electronics market trends from the point of view of the end customer. As all of us in this market know very well, we live in a world that demands connectivity everywhere, especially since our phones now double as expensive cameras. Because of this, consumer demand for smart devices that are waterproof and can be protected from the elements has increased. In the past, conformal coatings and sealants that are used for waterproofing were kept out of the personal electronic devices, so more could be sold after those devices saw moisture and stopped working. We are seeing a change in this with the release of waterproof devices. These new devices require different adhesives. In addition, consumers are moving towards thinner devices that can be worn or easily stuffed into pockets and travel bags. Furthermore, many of these thin devices, and even devices now in the home, such as the display pictured, have created needs for materials that have greater design flexibility. So how does that translate for designers and manufacturers of a smart device? Well, thin devices with smaller form factors require materials that can be precisely dispensed in a narrow bead. We're also working with a new set of substrates with different adhesion needs than traditional polycarbonate and aluminum, low surface energy substrates. Additionally, as these devices are now being set up in production lines or even traditional devices within the new manufacturing process, the need for reworkability of a device has become increasingly important. As we all know, if a device is manufactured with a defect that isn't discovered by the time it gets to the end of the production line, it can be very costly to the manufacturer. This adds hundreds of thousands of dollars in rework costs. The ability to rework a device has become a much more critical need. Manufacturers have always strived for greater efficiency in manufacturing. There is a desire to move away from double-sided tape, but materials currently on the market to replace the double-sided tape have their own challenges. Many devices have to be assembled within seconds of a material being dispensed onto a surface. The material often must be cured by heat or UV for a specified amount of time before moving to the next processing step. And finally, cost reductions. The market is demanding lower priced devices, which has forced OEMs to lower prices to compete. And OEMs, in turn, are putting pressure on their contract manufacturers to reduce the cost. Now I'm going to go ahead and hand it over to Ryan.
Thanks, Jason. My name is Ryan Schneider, and I'm the lead technical specialist on the development of new material solution that we're going to talk to you about today to solve the challenges Jason just shared. The latest product in our family of silicone hot melts is the EA4600. This product is very versatile, provides reliability and flexibility, and it can be used in many different applications, which we'll talk about in the next few minutes. Devices that use this product can achieve an ingress protection rating of 6.7 for water and dustproof and provide chemical resistance to common household chemicals. This product can be precisely dispensed in a narrow bead and has instant adhesion to many hard to stick to and traditional surfaces like polycarbonate, acrylics such as PMMA, PET, PTFE or Teflon, magnesium, glass, aluminum, and stainless steel.
So Ryan, you mentioned Teflon, and this is a substrate that many engineers I speak with have issues bonding.
Yeah, the surface tension of the EA4600 is less than the surface energy of the Teflon, and therefore it'll wet out onto the Teflon and create physical adhesion to the surface.
Gotcha, thanks.
This product can also be reworked after being applied without the need of aggressive solvents. This can reduce the overall device scrap rate and increase the cost savings. EA4600 has a long open time, which is the time after the product has been dispensed and prior to assembly. Traditional hot melt products need to be assembled within seconds. However, the EA4600 can be assembled up to 15 minutes after dispensing without affecting the overall adhesion strength. Since the device does not need to be assembled immediately, this can improve production efficiency and increase cost savings.
So between efficiency and costs, overall costs, how much savings have you actually seen?
Well, when comparing to the polyurethane hot melts, which are difficult to rework and thereby resulting in excess device scrap, the EA4600 produces greater cost savings due to the reworkability of the product. The EA4600 can be robotically dispensed as compared to double-sided tape, which is very labor-intensive and requires specialized tools for assembly. This can provide up to 5 times the total cost savings to the manufacturer. The next few slides, I will give some examples of applications where the EA4600 hot melt is currently used in production and potentially could be used. Here's an image of a mobile phone where the EA4600 could be used to seal the touchscreen window or around the mobile phone camera module, or provide sealing between two dissimilar materials like metal or plastic of the frame. EA4600 can also provide some protection against impacts due to the energy dissipative property that is common in a lot of silicone products. Similar to a smartphone, the EA4600 could be used in a tablet to bond and seal the touchscreen window, or the battery pack, or the camera module, or the back cover to the frame. It also could be used within the components of a laptop computer. For example, sealing and bonding of the window and camera lens. The EA4600 is ideal because it can adhere between dissimilar surfaces like plastic and metal. Silicone hot melt adhesives can be a good option for various plastic joint bonding applications, including wearable devices, since it has no cure temperature limitation and excellent adhesion to plastics. This gives more design flexibility to the manufacturers as they design their processes.
So Ryan, looking at the picture above there, there's a silicone earpiece, and it's a good time to mention that since silicone only sticks to silicone unless it's specially treated or primed, the 4600 would be a great option here.
Yeah, that's right, Jason. This is certainly an advantage of the silicone hot melt. It will adhere to other silicones exceptionally well, again, due to the lower surface tension of the silicone hot melt, which is even lower than the surface energy of other silicones. Now I'd like to give you an example of a 30 cc syringe package, which comes sealed in a vacuum pouch. The syringe is removed from the package and then inserted into the dispenser heater prior to dispense. Larger 300 cc package sizes are also available, which provide an even greater overall cost savings as a result of fewer production cartridge changeout cycles due to the product's long pot life, which is about 24 hours. Here you can see a pictorial of a general device assembly concept. First, the product is dispensed, and due to the long pot life, the product will remain dispensable after several hours while being continuously heated. Polyurethane hot melts tend to cure and char after a few hours of continuous heating. The EA4600 does not char. Then the device is assembled and pressed together, potentially up to 15 minutes later, due to the long open time. Polyurethane hot melts need to be assembled within seconds. Then the EA4600 achieves adhesion immediately because of its instant green strength. Jason, do you have any additional comments about pot life or open time?
Yeah, sure. So there can be some confusion between the meaning of open time and pot life in general when it comes to adhesives. In the case of the 4600, open time, work life, and assembly time are the same thing. And that's the time the material is open to the air after dispensing onto the part and before the assembly. pot life in this case is the usable life of the material while it's on the dispensing equipment at the temperature. And this is typically the time it takes the viscosity to double.
Thanks, Jason.
Now we're going to watch a short video of the EA4600 being dispensed in a narrow bead pattern. Depending on your bandwidth, it may take a few seconds to load. Regardless, though, the full version will be available on demand. The robot you're going to see is from our Fisnar division of Ellsworth, and Fisnar is available to do free video trials with this material on your parts, should you so choose. Key the soothing music. Right, Ryan?
That's right. All right. Well, I don't know. Maybe the video on some of your screens might have ended earlier, so I apologize for the dead air. But like Jason mentioned, it's kind of dependent on your bandwidth. So, well, with that, this concludes our presentation on designing with flexibility and reliability for consumer electronics featuring the EA4600 silicone hot melt. We can answer any questions at the end. Dow Corning also offers products in other consumer electronics applications. For example, silicone adhesives and sealants for electronic lid seal applications, coatings for component and PCB protection, module protection utilizing potting and encapsulating materials, and thermally conductive silicone solutions for temperature management. All of these different areas take advantage of the benefits of silicones. For example, the wide and stable temperature range and material flexibility in order to provide protection and adhesion.
So a little about us. Ellsworth Adhesives is the largest specialty chemical distributor in the world and has been a key Dow Corning distributor for over 25 years. We have a global presence with about 70 engineering sales reps here in the U.S. and 50 more overseas. And through our other Ellsworth divisions, we also specialize in custom formulations, custom packaging, low-pressure molding materials and equipment, and also liquid dispense through meter mix and robotics.
Dow Corning is a joint venture between Dow Chemical and Corning Incorporated and has been a global leader in silicone since 1943. We are headquartered in Midland, Michigan, with over $5.6 billion in annual sales. We offer over 7,000 products, and we reinvest 3 to 4% of our sales back into research and development of new products. We have over 60 offices and manufacturing locations worldwide.
If you have any questions, you can contact us at Ellsworth Adhesives or Dow Corning at the numbers above, and now we'll be happy to take your questions.
Hi, thank you so much, Ryan and Jason, for the information. I know everybody that is tuned in right now appreciates it. So we're going to move on to the very first question that we have here. Okay, so the first question is, what size bead would you recommend for a border width of 1 millimeter?
Ryan?
I'll take this one. For a 1 millimeter border, I'd recommend a dispensed bead with about 0.5 to 0.6 millimeter nozzle orifice diameter, or roughly maybe half to 2/3 the diameter of the orifice is about the width that you'd need to cover that area.
Now, does the product seal completely from water?
Devices that use this hot melt can achieve an ingress protection rating of 6.7. You'll see it referred to as IP67. And that is a protection, it's ingress protection, so that includes water and dust proofing.
So we'll move along down to our next question. So after assembly, what would be the typical distance between the two parts that are bonded, spread up, and thickness of the silicone layer?
There's very minimal squish out with this material. The material, even though it's a hot melt, it does cool rather quickly. so the squish out will be very minimal. But typically, depending on your bond line thickness, it's about half of the original dispensed bead width. So that's a good rule of thumb to go by when you're trying to determine how thick of a bead will you achieve after dispensing.
And what would the time to full adhesion strength be?
This product is classified as an RTV, and similar to a silicone RTV that you would use to seal up. It cures with a moisture cure or a neutral cure product that we call that. So it takes, even though it has this instant adhesion, which we call green strength, that's as it continues to cure and cross-link over time, it will build adhesion strength. And to get to full adhesion, typically, depending on your joint dimensions and kind of where it's located at, because it does require moisture to cure, and if you're in a confined area, that could slow it down. But a good rule of thumb, again, is about 3 to 7 days, and you'll have very nearly maximum adhesion strength.
Okay. So what kind of dispensing equipment would you recommend then?
Yeah, I can take this one. So you can refit your current XYZ robot. Ellsworth's Fisnar division carries different size robotics to meet your individual application needs. And like I said before, Fisnar offers free video trials, so we could find the right robot for your parts and help you out with that. You just contact your Ellsworth rep.
Okay, and I guess that kind of ties into the next question that we have here. Can you tell the people that are tuned in how they'd be able to get samples?
Yeah, absolutely. So if you contact Ellsworth Corporate, what will happen is we'll put you in contact with your engineering sales rep that's in your area, and we can set up either a call or a conference call or in-person meeting, however you want to do it, and have somebody out there, and we can either set up a video trial, or we also will have equipment where we could shoot out some of the material and you could actually test it.
Okay. Well, that sounds wonderful. Thank you both, Ryan and Jason, for providing some really great info today. Just want to put a quick reminder out there for everybody that if you have any additional questions for Jason or Ryan, you can always email them. I also want to remind people that you can also, of course, connect with us through any social media links. The webinar will be available at designworldonline.com by email. You can tweet the hashtag #DWWebinar, Facebook, Twitter, LinkedIn. This will also be discussed on engineeringexchange.com. So once again, I want to thank everyone for attending this webinar from Design World. And like I said before, you can always find this at www.designworldonline.com. Thanks for tuning in.
Thanks, everyone.
Thank you.